Welcome to this Purple Mash webinar. In this webinar, we're going to look at how you can get coding with TwoSimple's Freecode. We will explore the open-ended Freecode mode within ToDo, where children can explore, design, and create their own programs. We will look at how to use the full suite of commands and programming options within Freecode, how to create, scaffold, and set specific creative challenges for different levels of ability, and how pupils can share their coding with their friends and their families. Let's look first of all at how we find Freecode in Purple Mash. Freecode is found within ToDo, which is either accessible via the Tools area, and here is ToDo here, or if I go back to the home page and go into the Computing area of Purple Mash, you will again see ToDo here at the top in the Computing Tools area. ToDo is divided into three levels. You have Chimp level, which is the lowest level. It was designed for year 1s, 2s and 3s. And if I scroll down, you'll see Gibbon, which is designed for 3s and 4s. And then Gorilla level, which is designed for years 4, 5 and 6. If I scroll to the top, you'll see all of the Freecode resources grouped into one area. Freecode Scenes and Freecodechimp are both at Chimp level. These are a brilliant starting point if your children are brand new to using ToDo, or it's the first time that they've done some open-ended Freecode. Then you have Gibbon level and Gorilla level, which is the highest level. Let's have a look first of all at Freecode Scenes. As a teacher, I'm going to launch this. I could set it as a to-do for my class to access directly via the to-do area, and we'll come back to that feature a bit later on. But I'm going to launch this and have a look what it looks like. Now, Freecode Scenes, as the name suggests, has some scenes already set up for the children with some of the design already completed. Children can choose between a space scene, flowers and fairies, sky-high code, or spooky code. I'm going to choose the space scene. Here are all of the commands that are available to me that I'm going to use to program my code once I've decided what my algorithm is going to be. Let's click on the design button at the top right here and have a look at my scene. Now, as the programmer, I am going to decide what I have on my scene, what objects are on my scene, and you can see that the background is already set for them, and you've got 3 objects here already. If I click on each of those objects, you'll see the property value boxes that pop up on the left-hand side for that particular object. So I have Alien 1, Alien 2, and an astronaut. Now I want to put a rocket on my scene, so I'm going to use my objects on the left-hand side. You'll see there's a button object I could use as well, or I could drag one of these pre-made characters or objects onto my scene. Let's use this rocket here and pop him on the scene. Now he's a bit small. My astronaut's not going to fit inside him, so I'm going to use my property value box on the left-hand side to increase the size of that rocket. And I do that by clicking inside the scale value here and increasing that to the size that I want. There we go. Now I'm also going to call that rocket, at the moment it's called My Rocket 1. I'm going to change that and call it Apollo 13 and press enter. And I might change the astronaut's name as well. I'm going to call him Neil. Now if I exit my design and go to my code window, once I'm happy with my scene, I'm ready to program my scene. Let's just go back to the design scene for 1 second. One of the things I like to do as a teacher is to provide some scaffolding. So set the scene for them, and then the children's job, either individually or working with a partner, is to decide what they want to happen in this scene. So first of all, they need to draw up their algorithm. And I simply do that by using a little whiteboard with whiteboard pens, for example, getting the children to work together with a partner and write down step by step what they want to happen in their scene. And the questions I will ask the children are, explain the story behind your code. The second question is, how are you going to make your objects move around in your scene? Thirdly, how are you going to get your objects to interact? Do you want them to bang into each other? What's going to happen? Fourthly, for older children, I will talk about the sequence of events. Once the children have designed their algorithm, they can then program the scene using the code blocks and commands that are available to them here on the left-hand side. In order for my class to be able to access this scene that I've pre-created, I need to set it as a to-do for them to access via the to-do button on their home page. So I'm going to use my menu here and use the share button at the bottom. Now it will prompt me to save this work because I haven't saved it already, and I'm going to save it here in my teacher file, and I'm going to call it space scene and click save. I now have the 5 sharing options, and this is the teacher feature I need to use. Set as a to-do. I'm going to give it a title and a description, which will give my year 2 children an idea of what I want them to do with this scene. When you're setting a to-do, you can also add audio instructions so the children can hear you reading the instructions to them. Clicking on there will access the microphone on your device and you can record your instructions. As a teacher here on this screen, I can add objectives to this so I can do teacher judgments and assess the work after the children have completed it. Let's add the objectives I need. And if you are referring to our lesson plans in our computing scheme of work, which we'll have a look at in a minute, you will know exactly from the lesson plans which objectives to add. So I'm going to add Year 2, Computing, Computer Science, and it's these 3 objectives that I'm assessing by setting this particular task, this open-ended free code task later on. Let's click next. Give my to-do a start date. It will be starting from today's lesson, and I might give them a week to complete this. I could restrict this just to school or home use if I wanted to, just get them to do it at school. With the free code particularly, as it's a very creative experience, I want to give the children enough time to have a go at it, and they can start it in class and then finish it off at home. Let's click next and assign it to my class or classes. I'm going to assign this to class 2, which includes all of these children, and set that to do. So that to do is now been set. And if I come out of here and go up to my to do page, there it is. Now I can preview the work by clicking on this preview button, and there's my instructions that the children can click on as well. Let's click the preview button. And you'll see that it's set up exactly the way I saved it. Let's have a look at what that looks like from a child's point of view. If I click on the avatar up the top here and go down to this feature here called Impersonate Pupil Login, I'm going to impersonate one of the children in class 2. Here we go, Amelia McGuinness. I'm going to click the tick here, the orange tick, and she can just click the start button to go straight in to begin her code. If I click on the design window, Amelia will see the objects that I've added there as the teacher, and she can add others if she wants. Now, if she wants to change these objects, rather than having them the actual images that's currently on them, she can either double click on the image there and change it to any other character in our clip art library, and there are hundreds of clip art items she can change it to. She can search for something specific. I'm going to type in here alien. Let's have a look what other aliens I've got available to me. Fantastic. Let's have this guy. Now he's quite large, so I would need to teach my children about using the property value boxes on the left hand side. The property value boxes determine the state of that particular object the moment I press play. So on the left hand side, now remember this is chimp level, so this is designed for years 1s, 2s and possibly 3s. These are the property values that are available to them. When we start using Gibbon and Gorilla free code, the property values become much more open-ended. So first of all, I can change the name of my alien. I'm going to call him Bob. What is the movement of Bob? When I press play, at the moment, he's not going to move. So if I press the play button, Bob is there, but he's not moving. Let's press the stop button. So I'm going to change Bob so that the moment I press play, he is going to move in one direction. So I'm going to change it so that he moves right. Now, the moment I press play, even though my commands here are completely empty, there's no code on my code window just yet, the moment I press play, Bob is going to move right, because I changed his property values, which determines his movement, his actions, his appearance, the moment I press play and run the program. Bob's a little bit big here. Let's reduce his size a little bit so he's about the same size as his other alien friends and position him where I want him to be. The other property values on here that are important to understand what they mean is this one here, allow off screen. At the moment, if I press play and Bob moves right, as he does, the moment he exits the scene on the right hand side, he reappears on the left hand side. So he's not allowed off the scene. Let's press stop and go back to Bob, click on Bob again. At the moment, it says allow off screen, no, which means he returns to the opposite side of the scene every time he leaves the screen. So let's change that to yes. If I now press play and see what happens when Bob leaves the scene, he doesn't return now. Let's have a look at this property value at the bottom. At the moment, when I press play, Bob is showing on the screen. If I change that to hide, you'll now see that Bob is slightly greyed out on my scene. He is there, but the moment I press play, he's not there. He's hidden. He is actually there. In fact, he's moving right as we speak, but you just can't see him. So later on in my code, I might make him reappear, but I could do that using my commands. up here in the code window. So this is where I would get the children to work together with a partner and write down their algorithm or their ideas for what they want to happen in their scene in whatever sequence or order of events they want to happen. Now, while we're talking about planning our code, one of the tools here, if I come back into the tools area, this tool here called ToChart is a brilliant way to get your children planning their code. Let's choose the blank chart. I could drag some of these in here and just type inside them to plan my algorithm using this tool here called ToChart. So there's the plan that Amelia and her partner have worked out. Let's come out of here again and go back up to her to-dos, and she can continue working on her space scene. Let's see if we can program that algorithm using the code blocks that we know how to use. First of all, if I go back to my design window, I want the aliens to speak to Neil the astronaut. So let's go to my code window. When I click on alien number 1, alien 1 is going to speak. So I'm going to use this action option here. There we go. So he's going to speak. Now I actually want, if I press play and then click on alien 1, let's use a sound, and I'm going to nest this inside this click event and add that in there. I'm going to use my sound picker here. I'm going to click on this question mark. This is our sound picker, and there are some classic sounds, lots of other sounds in this drop-down menu, but I'm going to use this record button at the top right here, which will access the microphone on my device, and I'm going to pretend to be that alien and speak his words out loud. Hi, I am an alien. Why are you here? Now if I press play, click on alien 1. Hi, I am an alien. Why are you here? He's now speaking. Let's have alien 2 speaking. I'm going to use a click event again. This time I'll click on alien 2. Alien 2 is going to say something as well. Now, if I think back to my algorithm, I want Neil to realize that something's going wrong. He's going to speak back to the aliens, and then he's going to jump into the rocket. The rocket's going to blast off, and off they go. Let's run my code now and see what happens. Let's click on alien 1. Hi, I am an alien. Why are you here? And alien 2. You are not welcome here. Go back to Earth. Now, I want the rocket to take off with Neil in it. So what I'm going to do, I'm going to go back to my design. I'm now going to add a button to make the rocket launch. Using buttons is taught in year 2 when they start programming buttons in our scheme of work. So I'm going to use a button here, and as you can see on the left hand side, I've got some property values that will determine what my button looks like and what the text says, etc. And you'll see it down here. If I exit the design, it's now called rocket launch here in my objects area. Click on the design button. Let's go back to my button, and I want to change the text that's actually written on it. Okay, let's change the text color. Let's change the background here. There we go. There's my button. Let's pop it up the top here. Exit the design and go back to my code window. And now I can program that button to do something. So when I click on rocket launch button, what's going to happen? Neil is going to go right because I want him to move into the rocket. And then when he gets into the rocket, he'll disappear as if he's got inside the rocket, and then the rocket is going to blast off. So let's exit the design and see if I can code that. Now you'll notice I keep having to scroll down in my code window here because now I've added lots more code, and I've got the scroll bar on the right hand side, which will enable me to access my code at the bottom. I'll have a collision detection down the bottom. A collision detection determines what actions are going to happen when two objects collide on the screen. So I'm going to have when Neil collides with Apollo 13, Neil is going to disappear as if he's jumped inside the rocket. So Neil's going to hide, and the rocket itself is going to blast off up. And I'd like a sound that sounds like a blast off. So I'm going to drag this sound down in here and pop that in. And there is a pre-made sound here. I can preview these by clicking on the green play button. And then select this sound I want to hear. So let's press play and run my code. One of the things I do need to do, because I'm going to share this to my display board in a minute so my friends in my class can play my game, I need to put some instructions on it, because when I press play, it isn't immediately obvious what you need to click on and how to play the game. So I've pressed the stop button. I'm going to use this command here called an alert. I'm going to pop that up right at the top of my code. An alert is a brilliant way to write instructions on your code so that your friends, when they're playing it, know what to do. So I've now added my instructions inside that alert command, and I'm going to press play, and you'll see there is an alert there that tells the children who are playing my game what to do, and then I click OK and I'm ready to start. When children want to share their amazing code with their friends, they need to save it first. So if I use the drop down menu and click the save button. Let's now use the drop down menu and click the share button so Amelia can share it in a number of different ways. They can either share a link, and if I select that option there is the link I could copy and I could send that in an email. I could embed it onto a website. I could use the QR code there as well. If I go back to the sharing option, let's have a look at some of the other options. I could attach it to an email using our emailing service called ToEmail. ToEmail is a practice emailing server within the safety of Purple Mash. I could blog about it here if my class teacher had created a class blog for me to put that to, or I could use the display board, and this is the one I'm going to select this time. So I'm going to click on the display board. I'm going to add it to this particular display board here and click OK. It's now been shared to the display board. Let me come out of here. I'm going to save and exit just to make sure I've definitely saved it, and go back to Amelia's to-do page. And she can, if she wants to, she can hand this in because she's finished it. Let's hand it into the teacher and leave a note for her and a smiley face and click OK. Now it will no longer be on the child's active to-do page. It will be on her done to-do. As she's finished it, the teacher can now mark it, and there it is there. So I'm going to go back to being the teacher, click on Amelia's avatar at the top here and go back to being the teacher, and you'll notice the teacher now has an alert telling her that Amelia McGuinness has handed in a piece of work, and she could go to it here to mark that work. Alternatively, she could go up to, I could go up to my to-do area here, come down to the to-do that I want to mark, which is this one here. Let's click the view folder button, and there's Amelia's piece of work with her comment, and I'm going to click the mark button. Now when I'm marking her code, I can see the code window on the right hand side. I can press play and play her code, and I can do a number of things in the marking area on the right hand side. I can add rewards to this piece of work if I think it's a fantastic piece of work, which I do. Let's submit that. Amelia will now have a reward on her rewards tab. I can add a comment at the bottom here, and I can add teacher judgments. Now you will remember when I set this to do, I added 3 objectives to the to do, and I think Amelia, according to these 3 objectives, is exceeding on all 3 of these objectives from the National Curriculum for Computing. Let's click Save. If I felt that Amelia hadn't quite done what I wanted her to do, I could use this redo button at the bottom here, which would set it as a redo. It would come off Amelia's done to-dos and back onto her active to-dos, and she could pick up where she left off and then resubmit, saving a second version, which I could then compare to the first version, and both versions would be in here in the file area. So far we've had a look at Freecode Scenes. Freecodechimp is very similar, except in Freecodechimp they have exactly the same commands as they do in Freecode Scenes, but the design is completely blank. So the children's job, or your job as the teacher, is to set the scene and to choose which objects you want to use on your scene. And to do that, you can use the TV screen down the bottom here. Click on that TV screen, which will give you the property value box for the background. Click on this image question mark. Choose one of the pre-made background scenes, or you could paint your own. You could choose a file from your PC or take a photograph to be your background. I'm going to choose this one here as my background. Let's have a look now at something a bit higher level, Gibbon and Gorilla. Now, Gibbon and Gorilla are very similar in that they have the same commands, control items, etc. on the left-hand side. There are a lot more commands available to the children in Gibbon and in Gorilla. If you are using our lesson plans and our computing scheme of work, which we'll have a look at in a minute, then the children will learn how to program using these control commands here. They'll also learn how to program variables depending on what year level they are in. Now, in the same way as we looked at Freecodechimp, we can set our own scenes using this TV screen at the bottom here. Choose some objects. You'll notice there are more objects available to the children. We also have inputs and labels that are related to using variables. Some of these objects behave very differently to other objects, so it's important that the children understand that a turtle, for example, if I pop a turtle onto my scene, and if I then exit the design and program my super turtle, you'll notice the turtle's actions are very different to the actions of some of the other objects. So if I drag an animal or a character or something like that onto my scene, and I now use my animal, you'll see the actions are very different. So it is important for children to know the difference. And again, if you are using our computing scheme of work, following the lesson plans in there, then the children will learn how the actions of the objects differ. To finish off this webinar, let's have a look at our computing scheme of work. In the teachers area, here is our computing scheme of work, which has units covering the 3 aspects of the computing curriculum from year 1 all the way up to year 6. If I have a look at year 1, for example, and go into the coding unit here, unit 1.7, here are the coding lesson plans for year 1, which include these 6 lessons. Many of these lessons, such as lesson 5, use Freecode to teach the concepts of computer science. Let's have a look at some of the other lesson plans. If I go into year 4, for example, and into the coding unit 4.1, again, you'll have the year 4 lesson plans, or if your children have not had much coding experience or have never used ToCode in previous year levels, then the crash course might be the one for you. This coding crash course for year 4 includes these lessons. And if I click, for example, on lesson 3, again, it uses Freecodechimp and some pre-made scenes, such as this road scene, to get your children coding. For older children in year 5 and 6, again, you have the crash course if your children have not had much coding experience or have not used ToCode before. Perhaps they have worked through the computing scheme of work in previous year levels, in which case this is the unit to choose, which includes these 6 lesson plans. Let's click on lesson 4, for example, which has a selection of free code activities that are pre-made for you. Lesson 5 here, which focuses on user input, again uses Freecode Gorilla. Using the slideshows for each lesson will enable you as the teacher and the children to see what these commands do, and it will explain each command one at a time. It will also work through how to program each of these different commands that are used in Freecode. It will also give you example codes that you can click on directly from the slideshows themselves. In this webinar, we have looked at how you can get your children coding using Freecode Scenes, Freecodechimp, Freecode Gibbon, and Freecode Gorilla. Using Freecode enables your children to get creative with setting their own scenes, choosing their own objects, and deciding what they want to happen in their own code.